Number 8 then, from paper 2, the 2025 Advanced Higher Maths, this little matrix algebra question. 4 marks here. There's not actually an awful lot you have to do. First of all, it says, what about a cubed? Can you express a cubed in terms of just a and I? Oh yes, you can. Because a cubed is just a multiplying a squared. So it's a multiplying, and a squared was 6a minus I. So that'll give you a times the 6 can come to the front. You have to be careful with matrix multiplication that you don't change the order of the multiplying matrices. But I can multiply on either side, so can the inverse. So I've got 6, and then a times a is a squared, and I times a, I'll just put it down, or a times I can multiply either way around, gives the same answer. And then I can substitute that back in. So I've got 6 times, and then I've got 6a minus I minus, but that's an a, identity element for multiplication, leaves it unaffected, so it remains a. So now I've got 36a minus 6 lots of I minus a. So altogether I've got 35 lots of a minus 6i for a cubed. And in part B, find a similar expression for a to the negative 1, the inverse matrix of A. Well, you're just going to use this again. You'll get the inverse matrix if you can get a product that equals I, because a product of a matrix and its inverse gives you the identity matrix. So if I take this original expression, equals 6a minus I, and rearrange that to read equals I, so I'm going over that way, reading it backwards. So that will be 6a minus a squared. Well, that means I can take out, don't really want to put the 6 there now. I'll just write this first of all just to make it obvious. Didn't need to do that. Right, so if I take out the common factor of a, that leaves me with a 6 minus a. You would think, see, you can't just have the 6 there. It would be 6i. You can't just have a number on its own floating about. And that's it, because there you've got a multiplied by something gives I. Well, that must mean that the inverse is negative a plus 6i, to put it into that form.